Hey everybody, today we're talking about graphing simple rational functions. And a rational function has the form of f of x equals some function over or divided by another function. Keep in mind the root word rational is ratio, meaning division. Okay. Keep in mind also, we don't ever want our denominator to be a 0, because if the denominator equals 0, then it's an undefined value. Just don't forget that. So if we're talking about our parent function is this. Make sure you highlight that. Our parent function is 1 divided by x. That's what makes it a rational function, is that the variable is in the denominator. Okay, so there's a couple things we want to do, but anytime we want to try to start graphing something, we can always make a t-chart. So let's plug in these values and so what we get. So if y equals 1 over x, I know 1 over negative 2 is negative 1/2. 1 over negative 1 is negative 1. 1 over 0, remember that's undefined. We can't divide by 0, so we say undefined. 1 over 1 is 1, and 1 over 2 is 1/2. So we're going to plot those points. So at negative 2, if this is negative 1 here, negative 2, negative 1/2 would be about right here. Negative 1 is, whoops, right here. At 0, the value is undefined. So when x is 0, we have an undefined line here. We know it can't equal anything. So we do this like dashed line. At 1, it equals positive 1. And at 2, it equals 1/2. So because it's never going to cross that line, we also know it's also never going to have a value where y equals 0, because there's no value where y can equal 0. So it's going to bend like this. So we see here that there's two really important things. We see that there's a vertical asymptote here, and that's when x equals 0. We also see that there's a horizontal asymptote here, right here, and that's where y equals 0. These are super, super important pieces of information that we are going to start to look at first, because if you see, those asymptotes now kind of guide where your graph is going, because it can't cross them. So let's go ahead and graph this one. So if I'm graphing 6 over x, and we're going to compare it to that equation, let's make a little chart. And we use negative 2, negative 1, 0, 1, and 2. And then we'll get, if y equals 6 over x, we say 6 over negative 2 is negative 3. 6 over negative 1 is negative 6. 6 over 0 is undefined. 6 over 1 is 6, and 6 over 2 is 3. So let's graph those points. So here's 1 and 2. Here's 1 and 2 on the y-axis. Here's negative 1, negative 2. And here's negative 1, negative 2 on the y-axis. So at negative 2, so over to negative 2 and down negative 3, we see the point there. At negative 1, down 6, looks like this. So here's 3, 4, negative 6, something like that. 0, we know it's undefined. So it's like this. So it's like this dashed line right here. And then at 1, 6, so here's 1, 2, 3, 4, 5, 6. So this point here, and then 2, 3. So we see something that's going to look like this, but remember, it's going to have a guide. We also know there's nowhere on this line where any values are going to hit that x-axis where x equals 0, because when we plugged in x equals 0, we got an undefined value. So we also have these asymptotes at x equals 0 as my horizontal asymptote, and my vertical asymptote here is x equals 0, sorry, and this is y equals 0. So the rest of my graph is going to kind of be guided by those asymptotes. All right, let's do the rest. So here's the key concept. Once we are looking at our parent function 1 over x, translations or changes of that look like this. So remember, just like before, if I see something like this, I know this k on the outside is going to go, if it's positive, it's going to go up. If it's negative, it's going to go down. And this h is inside the parentheses with the x. So remember, that's our funky town. And it changes it horizontally. If it's positive, it's going to go left. And if it's negative, it's going to go to the right. So for number 1, in order to do translations of rational functions, first you're going to look at your asymptotes. You're going to draw your asymptotes first. We're going to start there because everything's going to be coming from those asymptotes, or that's the boundary. So x equals the h value, whereas our parent function was x equals 0, and our y equals the k value after the minus. So remember, this is your vertical asymptote, and this is your horizontal asymptote. So let's look here. We're going to graph negative 4 over x plus 2 minus 1. So remember, this is our h, and this is our k. So my vertical asymptote is right here. That's x plus 2, so that really means x equals negative 2, because it's always going to be opposite. Negative 2 is my horizontal asymptote. Oh, pardon. Vertical asymptote. Did it again. And my k value is y equals negative 1. So we're going to graph those two first. So when y, if this is my y-axis, y equals negative 1 here. My horizontal asymptote is the line that crosses that. And then we're going to look at x equals negative 2. That's negative 2 here. So this is my vertical asymptote. So everything from there is going to not cross those boundaries. Now we can use a t-chart. And we're going to choose values to the left and to the right. So go back up here, step 2. You're going to plot points to the left and the right of your vertical asymptote. So here we go. Our vertical asymptote was at x equals negative 2. So negative 2 is going to be my center here. So we're going to go negative 3 and negative 4 to the left, and negative 1 and 0 to the right. So I'm going to plug this in to this equation here. So if y equals negative 4 over x plus 2 minus 1, we're going to plug those values in. So we get negative 4 over x, which is negative 4 plus 2 minus 1. Well, that's negative 4 over negative 2 minus 1, which is going to give me 2 minus 1 is 1. And then here we're going to get negative 4 all over negative 3 plus 2 minus 1. So we get negative 4 over negative 1 minus 1 is 4 minus 1 is 3. And then we know here we should get an undefined value, which we will. We get 2 minus 2 on the denominator is 0. Anything we have at 0 in the denominator, we say this is an undefined value. And then negative 4 all over negative 1 plus 2 minus 1. We get negative 4 over 1, which is negative 4 minus 1 is negative 5. And we get negative 4 over 0 plus 2 minus 1. We get negative 4 over 2, which is just negative 2. Minus 1 is negative 3. So we're going to plot those points over negative 4. Here's negative 4. We're going to go up 1. Over negative 3, we're going to go up 3. And we can see this is going to follow those asymptotes like that. And then at 0, or when x is negative 2, we see that that's that vertical asymptote undefined. At negative 1, we go up, down, negative 1, 2, 3, 4. Here's negative 5. And at 0, it's at negative 3. So again, we're going to graph these, and they're going to follow those boundaries of my vertical and horizontal asymptote. And then, so our domain we know we can be any value except for x equals -2. So the domain, we say all reals except x equals -2. Another way to say that is from -infinity to -2 and from -2 to infinity. And then the range, it also goes all the way up and all the way down except for at -1. So we can say all reals except y is equal to -1, or we can say from -infinity at the bottom up to -1 and from -1 to infinity. That's it for today.